Okie dokie.
Hello.
Oh, that music was not good.
Oh, really? I was enjoying it. I was like dancing on my feet.
I was like, it's. I think I should.
Too much.
What?
You hear it too much. It's good.
Yeah, maybe. No, there's others, and I just chose that one today. And I'm like, oh, it's kind of fun in the beginning, and then I played it, and
no, I was into it.
yeah, it was fine. I guess you know what I needed more than that. I think I needed coffee.
Coffee, always coffee.
Yeah, it was okay. Yeah, okay. I mean, it's nobody died. That's all that matters. That's all we can do.
Today in the afternoon I was feeling super tired, and I had, I don't know, do you see this?
Cafe?
Yeah, so it's these like one of my coworkers, one of our coworkers, Gabby Brody turned me on to these at some point, like little chocolate, sort of like like the caffeine from coffee in a piece of chocolate. And
they have caffeine? Wait, it's the whole cup of coffee in a chocolate bar?
I don't know how much caffeine it has, but definitely. Oh, here it says caffeine dosage of 1 espresso, 65 milligrams, and only 15 calories. So I had one today. I bought them, like she first gave me one and it worked. And then that was like probably 6 months ago or 4 months ago or whatever. And then that was it. But then I found some, I feel like it was maybe on the way to Barcelona or something for Spring IO, but I've had them in my bag as just sort of backup, like in case for the jet lag or whatever. And then precisely today, I was like, I'm so exhausted. And I had a phone call with you and I was like, I can't be asleep when I'm in a meeting with Josh. So I pulled it out. I found it in my bag and I had it, and it worked.
That was a really good conversation. I was tired immediately after. I was like, oh, wow. My friend. Yeah, no, that was good. You just mentioned Spring IO. That was the last time we saw each other. That was a solid minute or two ago.
Yeah.
If memory serves. When was Spring IO? I don't know. Spring
IO. Last week of May.
May. Good golly.
Yeah, about 5-6 weeks. But the tweets are coming out of like the talks posted and like the viewership, and it's such a great conference.
It's such a good show, and somebody suggested that your talk was their favorite talk, and I saw that and I retweeted it because it was one of my favorite talks too. Definitely top 2.
Great tech. Kudos to Ollie. Credit to Ollie.
Oh, I mean, it's great tech, but this is why we exist. Is because if you write the best code and you do it in the basement and you don't tell anybody, then nobody will use it. At some point, you just somebody needs to like make the argument, and nobody does it as well or as elegantly as you, my friend. So I was really looking forward to a chance to talk to you. The video you did, the talk that is out there, by the way, and I just retweeted it, and I guess I can put it in the show notes. Actually, can I do that?
Yeah, and then the keynote is good. The keynote is it's like if you want the 15-minute version, go to the keynote, and then stay after that keynote because then you get the Josh and Christian Spring show, which is fantastic.
That was
one shot.
The Modern Monolith.
Modern Monolith was the talk. Yeah. I'm glad. Yeah, honestly, like I'm glad it came out so well because I say it at the beginning of the talk, but I had spent so much energy on the keynote. I mean, I had plenty of extra material that didn't fit in the keynote, but I went into the talk a little bit more like, I guess whatever's in my head is what's going to come out of my mouth. But it was good in the end, I think.
Great. Sorry, I'm updating the show notes.
Yeah, cool. Thank you for sharing.
No, thank you.
Yeah, it's kind of cool to have to be able to have some guidance on like architecture and code arrangement, which seems like like so foundational, but it actually is. It is foundational. It is critical. And I don't think there's been a clear answer before. There's all these different approaches and opinions, but now it's like, oh, Spring has an opinion, more or less, right? To some degree.
And this is where I kind of like. I don't. It's not like we did. It's not like we didn't try, but also I don't think we went nearly as far as we like. So we did Spring Boot, and I was out there telling people, oh, hey, Spring's a great way to pair program with the Spring team, and yeah, that checks out. But I think there's still a bit of a vacuum in terms of like how do you structure your code, and there's been alternative stacks that have encouraged their own. By adopting a stack, you adopt an architecture, and sometimes that's for better or for worse, right? So this is like in theory, Rails to me seems like it would be good if the architecture that it required wasn't so terrible. You know what I'm saying? Like it's there's nothing intrinsic to the idea or even the language that seems so off-putting to me. It's just the way that I'm supposed to write code just feels icky,
Mm-hmm. Yeah.
And so in that vacuum, I think we kind of left. There's a vacuum of how should you structure your code, and every application is different. So it's not like you can guarantee one size will fit all or whatever. But
yeah, and even Modulith is not like it's just talking about. I mean, so two things that come to mind when you say that. One is that like you're right, and like the Java compiler itself gives you certain visibility or access control, public, package, private, whatever. But there's a point at which if you want to start organizing your code into sub packages or different packages just to keep things a little bit organized for yourself, then you start to be forced into situations where you have to make things public, and they're public to the whole application, and they were public to the whole Spring Boot application. There's like the vacuum in the case of Java is really they're left by the Java compiler. And so even if you wanted to arrange your code in one way or another, which still Spring Modulith doesn't tell you, like if you're going to make sub packages, name them this way or divide them this way. It's just this idea of like top level package and sub package, and inside the sub package or sub packages, you do whatever you want. But at least like it's compensating for that, the Java compiler, which, even if the Java compiler forces you to make something public, at least this will, limit that exposure to just that package, that top level package. So you're right. Like the Java compiler left a vacuum, I think.
I think so too, but because it's also the compiler did, but and also I just think that it's sort of like did you ever take home ec?
I don't exactly know. What does that mean? Like, what is taught in home ec?
I don't know either because I never got to take it. But I think so the reason I think, and I could be wrong, but I think the reason that they don't teach it anymore is because it reinforced images of
gender roles
that maybe shouldn't be reinforced, or at least that was my vague understanding of the reasons why it wasn't ever taught. But so I agree, you shouldn't, like, under no circumstances should anybody be teaching girls how to cook in the kitchen or whatever. Like, yeah, exactly. This is, and only girls, don't do that, like that's wrong. On the other hand, there's some like basic stuff that all of us need, like balancing a checkbook.
Totally. Yes. Yeah.
Or something like that. I don't know. What's a thing that we all like? I don't know how to cook.
I don't like cooking either. But no, you're totally right. I mean, kids go to, at least in the US, right? Kids go to college and they are hounded by like these credit card companies that want you to sign up for credit cards, but they don't really explain like if you should pay, you want a credit history, so you want one, and then you want to pay your card off in full every month, not the minimum payment.
Yeah.
And, kind of that's your habit. That should be the groove you get into. And if not, it's going to be like a bucket with a hole that you can never fill with the interest rates. And I don't feel like anybody, if you get to learn that as you become an adult, it's just, I feel like it's luck. Like your family has to have a lot of teaching you or whatever. Like, and yeah, there should be a financial literacy or home ec or some kind of thing for.
And I think or you go to the school of hard knocks, which is way worse, right? And so, like, what I'm trying to say is I think that architecture should be like a stereotype enforcing software equivalent to home ec. You know what I'm saying? Like, I don't think enough.
What does that mean? Like, what stereotypes do you think it enforces that make it?
Home ec did, right?
Yeah.
Yeah. We don't want to be like home ec in that respect. But I do think there's room for a general discussion around the trade-offs and implications on architecture. And so we have our colleague Oliver Drotbohm, who is, well, first of all, just the coolest, but also he's just done an incredible job. I mean, he was for years the lead of Spring Data, and he was a consultant before that, doing really hard stuff for really amazing organizations hither and thither, and then more recently he's just been doing this like consulting internally, being awesome, and he's all throughout the whole thing this entire time, even when he was the lead of Spring Data, one of the most widely used open source projects in the world, and he maintained that role for like 7 years or 8 years or some incredible inestimable number. He still maintained these artifacts to help people learn how to structure their code.
Mm-hmm.
And you can see it. It is, even though it wasn't what he was the lead of, he was always working on like, okay, if I'm building a web app, what does that mean? Like, where do I put things so that they make sense for the next person to come along and get it, and also makes sense for the computers that have to execute it. He's just really, really high. What's the right word? Highbrow. I don't know.
I feel like there's something very academic about it. I think very, yeah. I think I don't know what the right word is, but I do get where you're going, and and it aligns. I mean, if there was some sort of, I guess, like with home ec, like you're putting your finger on like this feeling of like, is this the right thing? Are we teaching what we should be teaching, right? And I think with architecture, this is definitely like in alignment with domain-driven design, right? And so it is opinionated at the end, right? So, but I think these opinions have, at this point, I feel like they're time tested.
Yeah.
Yeah.
And I guess what I'm trying to say is, I wish we could all have like a university session, a class of 6 months with Professor Drotbohm. That would be great. That would be the neatest thing ever. But that won't scale as far as I can understand. My understanding of physics being what they are, I'm pretty sure that's not going to work. So having the ability to like
pair program with him on architecture, I guess.
Yeah, without actually having him.
Yeah.
I mean, he's there in spirit.
Yeah, and I feel like Spring Modulith does a part of it, and then I guess there's and I know I personally also need to learn more about this, but there's also the J Molecules project, which is also Oliver's baby, right? And which is adding annotations that are domain-driven design specific. So then because even in Spring, our annotations are technical in nature. So then if you could actually start to describe the code in annotations and in a more architectural way, then like it all starts to align a little bit more. And like I think one thing that I found is like domain-driven design, it's sort of it's hard to, like, it's easy to understand at some level, but then like to get good at it is hard. I'm not saying I'm not good at it, but like to get good at it is hard. But I think that having this as a path to it makes it easier and more approachable. And you sort of like can verify that you're getting it right a little bit more. It doesn't answer all the questions. Obviously, you still have to like identify your stuff, right? And design your application, but at least it's a little bit like you have some sort of a security blanket or some kind of guidance or some little hand holding that helps you, and it makes it easier to learn domain-driven design, I guess is what I'm saying.
Yeah. And so this, I don't know what you did. So domain-driven design, that's the Eric Evans book, right? And that was 2004. That's a good book, real page turner, like 1,000 pages, and understandably, I don't think people appreciate just how much of our modern nomenclature
I think there was 2 books, right? There was one that was more about like the concepts, and then there was one about the implementing it. I think by 2 different people. I wish.
Yeah, Vern Vaughn.
To be in the show notes. Well.
Yeah. But anyway, the core, but the original one was a very heady book, and I read, and you're right. They had somebody else. I want to say Vaughn.
Yes, that sounds right. Is it?
But
yeah.
It'll
I
come
actually have somewhere I have a slide with pictures of both of them.
Yeah. Well, the fact that somebody came along and did made a reputation just on having clarified what was in the first book. The second book only exists to make practical what was described in the first. But first of all, the first book is so not salacious. It's so worth the investment in time to understand it that it's not surprising that somebody else would write a book to then implement it, right? But that said, that clearly indicates that there's a bit of a gap in terms of translating the big ideas in the book to practical application.
Yeah.
Another thing,
sounds like another story I know.
This is our guy. It's Ollie, right?
Well, it also sounds like the origin story of Spring itself.
Oh, right. Yeah.
But yeah.
So Modulith. So he's got this incredible repertoire, like the repository.
Oh yeah.
That's a domain-driven design book pattern, right? Like that's, I mean, just these very simple things that we all take for granted today, that are every. By the way, Spring Data, the repository concept in Spring Data, came from Ollie, right? We had the at repository annotation in Spring Framework 2.5, but that was just it was a stereotypical, like UML stereotype, stereotypical annotation to describe that this class was going to serve as a repository, but it didn't provide that convenience. And fun fact, Ollie had this project, his side project called Hades, if memory serves correctly. And that's we brought that in. That became the foundations for what would later become Spring Data JPA's repository implementation. And then
it's like amazing how many things he's originated and pioneered. And the funny thing is, like, he's a musician, he's like he's a legit musician. And there's people in the world who know him as a musician who does some tech on the side. Like, if they only knew the tech that he's doing, the difference he's made to the Java world.
Right. So then we get to, like, here we are, 15 years later or whatever, and we're talking about this project called Spring Modulith, which I love, and I know you did an amazing talk as we opened the show talking about.
I felt like when I learned about it, I felt like it was the project that I had been waiting for at least 10 to 15 years. Like, from my early days, learning SOA or whatever, I was a consultant for, back in the day, I don't know, Sun or Oracle or whatever it was. And like, just learning, going to a customer and seeing their SOA applications and helping them and seeing how everything functioned. And just this feeling that there was this gap, and we went on this whole microservices journey, but there was like never answers to certain questions. And then suddenly, here's this project. And it was like amazing.
With concrete answers.
Yeah.
So let's talk about that. What is a modulith? Well, first of all, what is, like, it sounds like a monolith. Is it? What is that?
So yeah, I mean, it's a monolith in the sense that you're talking about one code base, right? So in the case, because we're in the Spring world, it means one Spring Boot application. I mean, I think there is a scenario in which you could use Modulith without Spring Boot, but right now the way that Spring Modulith right now is, intended to piggyback off of Spring Boot functionality, like scanning code and whatever, right? So within one Spring Boot application, Spring Boot sees the whole code base as one thing, right? You have your main Spring Boot class, and that's the one you annotate as Spring Boot application, and then all of the package scanning is just from that root. The whole thing is one app. And so what Modulith does is it takes that package scanning, but then it narrows it and says, I'm going to scan every top level package in this application is going to be considered a separate module, separate functional module. And so then it has the capacity to apply that scanning in, down these vertical slices. And so that it can tell you if there's any cross referencing of code from one vertical slice, one module to another, that shouldn't be there. It employs this idea that if anything is one sub package lower, one package beneath the root package, that's a way of saying this is, and this is internal implementation of this module. And it's almost like if you had a microservice,
Right.
it's really easy with a microservice that you deploy separately, and it's a network hop to say, these are the APIs that are exposed to the outside world. Everything else is my own implementation. I can change it as I want. I can write it in whatever language I want. Of course, here in Spring Boot, it's all Java. But so similarly, like a module in this single Spring Boot application, anything that is public and that is at the top level is your API, so to speak. But anything that is in a sub package, even if it's public, because that's where the compiler fell short for us, right? So
Right.
as long as you put it in a sub package, even if it's public, Spring Modulith will say, okay, I'm not going to let that be visible to anything else outside of that particular module. So then your application, now you read your code, and like every top level package is a functional module. And then inside of that, you can have, of course, you can have things be package private anyway, or you can like drop them, just move them into a sub package,
Right.
and it's a protected implementation.
And so that's going beyond the visibility modifiers of the
compiler
alone, right?
Yeah.
Okay.
Yeah.
Augmenting it in a way.
Yeah. You're not taking away, right? Like, so if you have something at the top level that is package private, then it still can't be seen by another module. So that's, you're not going to, it's not reducing, it can't reduce the Java compiler, but it will add where the Java compiler forced you to make things open.
Yeah.
Now those things can be not so open.
So, and the use case here is I'm in a large or even just a small but well-structured code base. And these packages, so basically modules are packages. What are these packages like? Why use a package as opposed to, like, why not just have a giant flat open namespace like C? Like, I know this is like foundational, but
make it spaghetti column where everything talks to each other. And yeah, that's the we've spent 20 years trying to get out of those messes where all the code is just interdependent and hard to test and hard to evolve and hard to understand. And yeah, so I mean, that's the thing about microservices, right? Like microservices, because they're like separated by network hops, and each microservice is a separate code base, like it forced that separation between components. But like, it's a pretty extreme solution to say that the only way you can enforce that discipline is to go all the way to a distributed system. Like that's, whatever the opposite expression to throwing the baby out with a bathwater, you know what I mean? Like you want to take one step forward and you're forced to like jump off the cliff into distributed systems.
Right. Which is like that's the old, I don't mean to, I'm not likening them exactly, but it does remind me of a great metaphor from Bruce Tate's book, Bitter EJB, from like 20 plus years ago. And it's, again, imagine a whole book about the cons of a technology, like as opposed to the pros. Like it's, I believe that technology existed. It was so bad. Anyway,
pros about the cons.
No, just, yeah, exactly. I mean, it's just the whole book was a diss track, like incredible. And he talked about having to eat the whole elephant, right? Like technology was so hard, and you had to you couldn't just. I don't know anybody who eats elephants, and I don't want to, but
we've been eating elephants for 10 years.
Right, exactly. Like people. So I don't think microservices are nearly so bad. Obviously, not even close. I like microservices, but nonetheless, they are. You very quickly find yourself it's you can do it piecemeal. You can take it. I mean, we have patterns like strangling the monolith. That it is possible, but nonetheless, it does take
I mean, even if you're strangling the monolith, you're still, you're saying, okay, I identify this piece of my monolith that should be a separate microservice. So you actually have to like move or rewrite the code, put it in a different code base, and then you start to manage traffic. Some of it goes to your monolith and some of it goes to your new microservice. So now you've got traffic management, plus you have two processes running,
right.
And you progressively, so it's complicated. I think there's a lot of monoliths that have not been refactored precisely because to refactor them means infrastructure management, traffic management,
Right.
multi-process management, and it's multi-repository management. Like it's hard. There's there's a trade-off. There's a very big trade-off. And so hopefully with Spring Modulith, and that was one of the things that was released just a week before Spring IO. And so we were able to announce it, that this open modules, to be able to, if you have a traditional, non-refactored monolith and you want to move it into a modulithic architecture using, you make it a Spring Boot application, and then you can start to refactor, but you do it in place. All you're doing is moving code into a package, which is much easier than moving code out and moving it into a separate code repository. You're just like literally rearranging, your packages get rewritten. You're like, so, and then you don't have to traffic manage. You don't have to change traffic management. You don't have to deploy anything differently. Same CI/CD process that's been working for you with a monolith will work with a modulith. Yep. And so the whole refactoring story, it has sort of like these new possibilities for the monoliths that people haven't wanted to touch.
Right. And with a modulith, we have like, how do we choose what package? Like, what do I, like, okay, we agree, namespaces, good. What am I looking, what's the grouping, why put things in a package and some things in another package? Is it by the type of component?
I mean, it's the same. So I think there you go back to sort of domain-driven design, sort of event storming and things like that, right? Like all the strategies about looking at your system and identifying what should be what's the word? Your
aggregate bounding context.
No, I guess I'm looking for a word that starts with a D.
Domain.
Maybe it's like, I think I'm looking for a different word, but like what are your domains like, right? Like what are your functional components?
Right.
Think about your code functionally, not technically, right? Like we're not looking for the data layer. We're not looking for all the code that manages the data layer. You're looking for the code that represents, like, you have a system, right? Like your order system or your inventory system or something like that, right? Something functional.
Okay.
Mm-hmm.
So not
functional design. Right. You're identifying the functional design, the functional components.
That's cool.
Yeah.
And so we talk in software design, we have this concept of efferent and afferent. I forget which is which, but one is how many types depend on a given thing, and then the other one is how many things a given type depends on. Or that is to say, one's a measure of how dependent upon a type is, and then another one is a measure of how many dependents a type has, or dependencies a type has, right? So inbound versus outbound, or something like that. I don't know. Anyway, and that number is really, it's, lower is better, right? You don't want to be you don't want to be coupled at all if you can be, and you certainly don't want to be tightly coupled to more than a few things, or if at all, if you can be as encapsulated as possible, that seems like a good thing. And to that extent, putting things in the same package by role, by technical scope, like controllers versus services, whatever. If you had a bunch of services and they're all in the same services package,
right,
it's too easy. It's too easy for these things to start getting in a knot, right?
Yeah, exactly. Yeah. Well, when you draw all those efferent afferent lines is when you can visually depict the big balls of mud, or the spaghetti, or whatever. I guess it's the big ball of mud, right? The proverbial ball of mud. Yeah.
And then that same, exactly what you just said, but then scale it out to, by the way, every time you untangle one of these, you're also changing DNS, because if you think a big ball of mud is bad in a modular, in a monolithic code base,
right. There's no well, yeah. So right, that's
microservices.
Yeah, there's no guarantee that because you went to microservices that you don't have too many interdependencies, and as such still deal with a lot of the rigidity and complexity of what was spaghetti code. Yeah, I mean, I think, for Moduliths as well, right? Like there's always going to be an element of human decision, and human design, but to that point, like the more that your code can tolerate and support you in refactoring, it's much easier to refactor code, the
Yeah.
arrangement of code, if you're in one application, one Git repo, than if you had to, like, every time you want to refactor, you got to touch 5 different Git repositories. Like that's more complicated.
Too many moving parts. Yeah. So I really like this Modulith project. It also gives it gives so it's not just when we talk about Modulith, it's actually backed by logic, right? There's actually something there in the project, in the tests and so on.
Yeah.
It'll steer you. It's not just a README saying read this and then you're free to go.
Right. So when you were talking about sort of like Ollie over time, pioneering these ideas and converting them into something more concrete that was usable, and then eventually part of a Spring project. One of those, I feel like there were two really key moments between the time that, because Ollie, 2012 or so, he was touring conferences and he was already talking about these ideas.
Yeah.
But he didn't have he didn't have an implementation for it. But then, what was it? Is it 2011, 2013? Spring Boot was created?
Yeah, 2013 we went, and 2014 we had GA 1.0.
Right. So just the creation of Spring Boot was one thing, right? Like this idea of this application scanning and this stuff. And then a couple of years later, I forget the year exactly, the ArcUnit project was created, and there were other projects already that were enforcing architectural rules on code, right? That would analyze the way your code was structured and the visibility, and that would, but ArcUnit was one that allowed you to write your own rules, so it could be extended, and also it worked with any testing framework. So it worked like with JUnit, for example. And Ollie was looking for a way to implement his ideas in a way that was very plain Java. And so ArcUnit really answered that need for him. And so then he had Spring Boot and he had ArcUnit, and those were the two key moments that had to happen so that Ollie could go from talking about it to, creating something that people could reuse. And he maintained that for a couple of years. He had a project that was he was, as you say, he was a lead for Spring Data. And because he had such a passion for these ideas, on the side and his free time, he had this project called Moduliths that was based on Spring Boot and ArcUnit. And so, so he wrote the rules in ArcUnit, and he wrote support that through tests. You can run these, these rules are executed on your code, and you get notified if your code is, compliant with these ideas of how packages should or should not depend on one another. So ArcUnit. So it's kind of an opinionated implementation of ArcUnit on a Spring Boot project, I guess.
Amazing. Really, I mean, it's just such a brilliant project, and it's not hard to get started.
Easy.
Yeah, because it's just, first of all, it's just your existing code base. You can just start modernizing it and refactoring, and it is rigid, but there's also escape hatches. So if you want to slowly move into it, and you want to allow it to leak certain types and make them public, whatever, it's right. Not all or nothing.
Right. You could add Modulith libraries to a Spring Boot app that is entirely a spaghetti, traditional monolith, and then you could, as you say, open these hatchets and just kind of let these things slide, and then slowly, as you refactor, then start to say, okay, apply opinions here, apply opinions there, but don't apply opinions over here. Not here yet. This part's messy.
Yeah, exactly.
Don't look here.
So good. Yeah. So it's really an amazing.
It's cool, and then it has all these other great features. I think I also so I did the keynote for it for Spring IO, right? So I had to come up with sort of this 15-minute, how do I condense as much as I can about it and make it in a way that's clear. And I ended up sort of categorizing the things that it does into 3 main groups with 2 things in each group. And so that every time I have to think about like what Spring Modulith does, it helps me to go back to that grouping of ideas. And so basically the 3 main categories were verify, visualize, and integrate. And within each of those categories, so we're talking about verification, it helps you verify the modularity of your code, right? That you've arranged code properly, that your visibility rules are good, and you and it applies that through this verify test method. So you just, when you're running your test, you run a test method, and it'll tell you whether or not you comply with modularity rules. These are QA rules. Right. But you can also verify the functionality of an individual module, and that's because it, in the same way that Spring Boot allows you to slice up applications horizontally, like across data or web, Spring Modulith adds the ability to just load one module or a module and its dependencies to run a test. So now, even though you don't have things in separate apps as microservices, you can actually load and test one module at a time. So that was verify. And then visualize, it generates documentation. So you get these, pretty diagrams and tables with, relevant information, not about the implementation, but about the architecture. And also it supports distributed tracing. So you can get this visualization of traffic where before, the only way you can get distributed tracing sort of by default in a system is if you have network hops, right? Distributed tracing shows you network hops across the microservices. But now you get them between modules in one Spring Boot app, distributed tracing inside of a Spring Boot app. And then the last one was integrate, right? Integrating, if you're integrating 2 modules that were previously tightly coupled, then you can do that through events. You can either do it in memory, or you can just publish events to external systems. And it has support for that also. So that's the way. So verify, visualize, integrate is how I now, it's my sort of mnemonic for.
That's a good idea. I like that. Yeah. So how do people get started? Well, they should go watch a talk. Spring IO. Go watch that. Show notes. I did the thing.
And then watch past the end, because after I get off stage, then you have the real star.
No, that's the modular monolith, the good one. That's the good one. That's the video.
Well, after we have Josh and Christian Solov, who's the.
Now you're talking about the keynote.
Spring AI stealing the show. It's amazing what Spring AI is doing.
You and I are going to be doing we're going to be at this other spring themed show, and spring one, and that'll be fun. I can't wait for that. I think people can. How does that work? Can they register? Surely. Let's see. Sign up. Join us in person. Yeah, just go to spring1.io and do the thing. Click on the buttons. It's August 26th to 28th in
Las Vegas. Hot and humid Las Vegas.
26 to 20. Yeah, that's gonna be fun. That'll be fun. So go there now and register.
At the peak of summer.
in the desert. Yeah. No, it's no, but it's always springtime when there's spring.
Always springtime.
And on that bombshell. Thanks for having.
Yeah. So that'll be another opportunity for us to merge the 2 stories into one.
Yes. Don't miss it. We're not going to say what we're talking about, but trust me, you might find out eventually. No, you're going to love it. There, that's the right one.
You're going to love it.
Thank you, my friend. I appreciate you taking.
It's such a pleasure, Josh.
We're
for having me here.
It's July, and it's been like 6 weeks since I saw you. I'm really glad we got to chat.
Me too. Yeah.
Bye, everybody. Thanks for hanging out. Bye.